Hello and welcome to the Daily Space for today, December 3rd, 2018. I'm your host, Dr. Pamela Gay, and I am here to put science in your brain. In today's top stories, we have a story that hopefully many of you were with us to share just a few minutes ago. About 1 hour ago, about 1 hour ago, the OSIRIS-REx spacecraft entered orbit around the Bennu asteroid. This space rock is in an orbit that is very similar to Earth's orbit. It's what's called a near-Earth asteroid. The particular orbit that it's on is one that makes it very easy for us to get a spacecraft there, and more importantly, to get that spacecraft back. OSIRIS-REx is going to map out this little rock, and then, with hopefully the help of some of you, we're going to map out the world, find a rock, bring that rock home, and try and understand the origins of our solar system. Asteroids can form in all sorts of different locations, and they do get moved around throughout their life. And there's a chance that this particular asteroid didn't form exactly where it's located. But if it did, it contains the same ingredients that would have gone into forming our own planet Earth. And unlike the stuff here on Earth, it hasn't been subjected to rain, weather, humans, volcanoes, and all the other things that reprocess material here on the planet Earth. So that rock gives us a chance to essentially get the raw cookie dough batter of our planet, or perhaps another planet, because as I said, this world might have formed somewhere else. Wherever Bennu formed, we are going to get a kind of sample that we've never had before. We're going to get images at a resolution we've never had before of this particular asteroid. And here is to hoping everything goes fabulously with the OSIRIS-REx mission. Now, continuing out through our solar system, the next story we have is one of odd water. Saturn and its rings are often very watery systems. We have chunks of ice making up the debris in the rings, which is generally many meters across, and that ice appears to be the same kind of ice that we have here on Earth, by which I mean the ratio of deuterium, which is heavy water, to regular water, or rather regular hydrogen in the water, appears to be the same for the rings, for most of the moons, for, in fact, all the moons that we've been able to study, except for Phobos. Phobos is a weirdo. Phobos has a ratio of deuterium to regular hydrogen that is like nothing we've seen before. It is way too high. Now, what this means is Phobos formed somewhere else and then somehow got captured gravitationally by Saturn. Remember that thing I said just a minute ago about how asteroids don't always form in the places that we see them today and things got shuffled around? Well, some of the things that we now perceive to be moons, in fact, probably formed on their own independently somewhere entirely different in our solar system. We think this might be the case for Mars moons Phoebus and Deimos, and we also believe that Neptune's moon Triton is in fact a captured Kuiper Belt object. Now, making this particular world even more unusual, Phobos's, I'm going to mispronounce this world over and over. So Mars has the moons Phobos and Deimos. Saturn has the moon Phoebe, which is what we're talking about today. I'm sorry about the mispronunciation. Phoebe is the one that has the extraordinarily high deuterium to hydrogen ratio. Now, in addition to measuring the deuterium to hydrogen ratio, scientists working at the Planetary Science Institute, which is where we're produced, so these are some of our colleagues, Roger Clark led this research. They also just trying to see how much like and unlike the Earth these compositions are. They also looked at the carbon-13 to carbon-12 ratios. And they found that for the other moon of Saturn that they looked at, it looked just like Earth. But again, this was a completely different ratio for Phobie. So this world definitely formed somewhere else, don't know where, but it wasn't there. And that's kind of cool and lets us know that, well, here is one clear case of a stolen object. Now, the other cool thing about this is we've often been trying to figure out where the water on Earth came from, and now we know that the kinds of objects that ended up becoming the majority of Saturn's moons, and in fact its rings as well, were the same kinds of things that careened into Earth, bringing us our water. Okay, I have another story of planetary discoveries, but this is a story that takes place out of our solar system. In the final days of Kepler's K2 mission, it downloaded a myriad of data that is still revealing new worlds. Recently, an international team of scientists led by folks working at the University of Tokyo and at the National Optical Astronomy team in Japan were able to go through and observe more than 200 of the planetary candidates from K2's last data download. In following up on all of these candidates, they recovered 107 objects that proved to be real exoplanets orbiting other stars. So the number of more planets in our solar system just went up by another 107. And like so many of Kepler's discoveries, all of these worlds are unique. Some of them appear in multi-planet systems, some of them are alone. They come in a myriad of sizes and distances from their stars. It's going to be an exciting time as we work to figure out how these worlds change our perspectives on how planets form in our universe. Now, in one final story, I have what may be the most confusing graph of the day. When I first looked at this, I actually didn't know what I was seeing. What this is a plot of known black hole mergers and known neutron star mergers, and then additional known neutron stars and black holes. So where you see two blue objects that have arrows going up to another blue object, each of those represents the mass of two black holes that merge together, and then the mass of the resulting object from their merger. Now you'll notice that in general, the new object doesn't have the sum of those two original masses as its new mass. This is because during the merger process, vast amounts of energy are radiated through the universe, both in the forms of a supernova and also in the form of gravitational radiation. Gravitational waves, in fact, that can be detected here on Earth by LIGO and Veritas. This weekend, the Gravitational Wave Physics and Astronomy workshop that was held at College Park, Maryland, went over a new analysis of all of the detections and possible detections that had been made by these gravitational wave detectors. In the process of reanalyzing the data, they were able to find, as they should have, all 6 of the previously published gravitational wave events. This includes the neutron star event that was seen, and I meant LIGO, Virgo, measurements, not Veritas. So sorry. I have a cold and I'm streaming on cold medication. Please be forgiving. So they were able to recover all of the past known events, and they recovered 4 new unknown gravitational waves in the existing data. This is why you never throw out raw data. By reprocessing it, you can often find things that were always there, but just didn't appear in your earlier, data reduction pipeline. So one of these events actually turned out to be the largest known gravitational wave black hole merger to date. This was the event GW 170729 that was, well, as its name would imply, detected on July 29th, 2017. This is an event that in reality occurred about 5 billion years ago, but that gravitational wave took time to make it all the way to our planet. In this case, the amount of energy that was given off in gravitational radiation was the equivalent of 5 solar masses getting converted into just gravitational radiation. So that E equals mc squared, take 5 of our suns, turn them into energy, and put all that energy into shaping and reshaping our universe as that wave permeates through space, stretching and squishing things as it goes. The result is that 80 mass object that you can see. Can you see my cursor? Yes. So these two objects this object and this object merged into this object, and this is the one that we're talking about. It resulted in an 80 solar mass black hole and radiated away, just in gravity, 5 solar masses of energy. So this is starting to give us a sense of what LIGO and Virgo are capable of seeing. And hopefully we will continue to get more and more of these events over time. Now, I'm going to very quickly take some of your questions. And while I do that, I'm going to work on pulling up the feed for today's spacecraft launch. Today is a day that is basically all science all the time, and that's okay. It's just a little hard to keep up sometimes. On the list of things going on, well, we already had that encounter of OSIRIS-REx at Bennu, and now we're waiting for the SpaceX feed to start. We are showing a 12:32 launch. So let me see what I can do to get this to work. I'm going to have to flip scenes for just a minute. When I come back, I will answer your questions. So hold on just a moment while I switch scenes. Sorry about that. So we're getting ready for a SpaceX launch that will happen in just a moment. I need to change the title on this. We were not fully prepared for so much sciencey goodness to arrive in one day. So this is a ride share. I love the fact that they're now referring to spacecraft as ride shares for SpaceX, where we have payloads getting launched into sun synchronous orbits going around the Earth. Payloads include a whole myriad of different Earth-looking satellites, including what they're referring to as a flock of doves. I am figuring this out in real time. I appreciate your patience while we do this. So SpaceX still isn't sending us out any audio. well, they have audio, but it's music. So I'm going to not subject you to the music. Let's see what I can find out. It's one of those crazy days where you start to realize that humans really are a spacefaring race that is getting to the point that we just kind of launch when we feel like it. Space, no big deal. Here we come. This launch is going to take place from Vandenberg. So this is a West Coast launch. And sun-synchronous orbits mean that this is going to be a polar orbit. So the spacecraft, as they orbit, will be going over the North and South Pole approximately. And as they orbit over the Earth, they will always encounter the same relative sun surface angle for their images, allowing them to see shadows in the same place over and over. Okay, here we go. The feed is going live.
Good morning from SpaceX headquarters here in Hawthorne, California. This morning's Falcon 9 launch is scheduled for 10:34 a.m. Pacific Standard Time or 18:34 Universal Coordinated Time. Our launch window is just under 25 minutes long and closes at 11 a.m. Pacific Time. I'm Lauren Lyons, a senior engineer in our Flight Reliability Department, and welcome to the webcast for the Spaceflight SSO-A Smallsat Express mission. For this mission, we are flying a record 64 satellites for our customer spaceflight. This is the largest number of payloads ever launched from a US-based rocket. This flight is also particularly exciting for SpaceX for another reason. We'll be flying this Falcon 9 booster for the third time. Now, this is the first time we've ever done this, which we'll talk more about later on in the webcast. Following the liftoff, we have 2 recovery attempts. First, we are attempting to land Falcon 9's first stage on our autonomous spaceport drone ship, Just Read the Instructions, which is situated in the ocean 50 kilometers away from the launch pad. The second recovery attempt will be to catch our payload fairing with a large net on our boat, Mr. Steven, as that fairing descends down over the Pacific Ocean after separating from the second stage. And if you've been following us closely, you know that we're still early in our fairing catching efforts, but maybe today will be the day that we net one for the first time. And finally, once Falcon 9 reaches its intended orbit, the 64 satellites will be released in 6 separate deployments, starting at around T+14 minutes and ending approximately 43 minutes after liftoff. Now, because all of the deployments take place over areas of the globe where we do not have ground station coverage, there will be no live video feed of the spacecraft deployments on today's webcasts. So we'll wrap it up right after shutdown of the second stage engine, approximately 10 minutes after launch. However, we will be posting updates on Twitter about the deployments, starting at when we regain ground station coverage around an hour later. Now let's take a look at Falcon 9 on pad Space Launch Complex 4 as we count down to liftoff.
Hi, I'm Kate Tice, and I'm a program reliability engineer here at SpaceX. We're looking at a live view of the Falcon 9 rocket at our West Coast launch site, Space Launch Complex 4 East, or SLIC 4 East at Vandenberg Air Force Base, which is just a couple hours north of where I'm standing here at our headquarters in Los Angeles. Falcon 9 you see here is 70 meters tall, which is just over 21 stories high, and most notably, our first stage is covered in soot. As Lauren mentioned, this is the first time that SpaceX will be flying a Falcon 9 for the third time. So all of this that you see here is from not 1, but 2 previous re-entry missions. Multiple reuse is being supported by our Block 5 upgrades that we debuted earlier this year. Our Block 5 rockets are designed to be capable of 10 or more flights with no scheduled refurbishment. In fact, this stage that you see here previously supported the Bangabandhu 1 mission in May of this year, which was our first Block 5 flight, and that was then followed by the Miraputi mission that was this past August. With a successful launch this morning, this booster will have launched from each of SpaceX's 3 launch pads, Slick 40 and Launch Complex 39A, which are our 2 pads at Cape Canaveral in Florida, and now Slick 4 East at Vandenberg, which makes today's mission the very first SpaceX launch pad hat trick. So in our 17-foot in diameter fairing here, we have 64 satellites. As mentioned, this fairing we will be attempting to recover it today. Hopefully today we can actually manage to snag it. This attempt we will be aiming to catch it and recover the fairing in the supersized net that you see there on our recovery ship called Mr. Steven. That's currently stationed in place out in the Pacific Ocean in preparation for today's attempt. Now, we are early in our efforts to recover our fairings, and if today is not successful, we will continue to iterate until we get it right.
The fairings are not controlled. They just fall. That's a speedboat where they're basically going to go around the ocean going, I got it, I got it, I got it, I got it, trying to catch the protective coating from the satellites as they flutter through the atmosphere. So they're talking about how the spacecraft are now filled with fuel. We're 6 minutes before launch and we're getting ready to go. This is one of those things that is just going to be kind of awesome. Now, earlier there had been a question. Why are we using Vandenberg and Cape Canaveral? And you may have seen other launches on the stream that we're launching from French Guiana. Each of these different locations has its different pluses and minuses. The closer you get to the equator, the more the rotation of our planet adds extra horizontal velocity to your spacecraft, helping you get into geosynchronous orbit, helping you escape Earth's orbit altogether as you head off to the moon or beyond, as Solar Pocket Orbiter did a few months ago, or I guess it was a few weeks ago. Now, with sites like Vandenberg, it's also really good for going into polar orbits. These are orbits that are going over the poles of the planet, and we'll always see the surface of the planet with the sun casting the same kind of shadows. This makes it very easy to see changes in the surface of our world from one day to the next. Thank you so much for the follow, Everyday Engineer. So I'm going to go over to the SpaceX audio.
Payloads being sent to space. Spaceflight SSO-A SmallSat Express is an exciting mission. These include 15 microsats and 49 CubeSats from both commercial and government entities from a total of 17 countries. This morning's mission will be headed to Sun-synchronous low Earth orbit, which is what SSO stands for in the mission name. Sun-synchronous orbits travel over the Earth's poles as the planet rotates underneath, with the satellite passing over a particular section of the Earth at the same time each day. Sun-synchronous orbits provide a constant amount of sunlight, which makes them especially good for imaging satellites, of which there are several on today's flight. Let's check out this clip from Spaceflight with more info about today's payloads.
At Spaceflight, our mission is to make space accessible to all. We provide the most opportunities as anyone on the planet for small sats to get to orbit. The rideshare model makes space really accessible to everyone. This model lowers the barriers to entry for people that want to get small sats on orbit. And this enables all kinds of new business plans to come to fruition by really enabling lower cost launch for everyone. The SSO-A mission was all about getting small sats on orbit. They've historically been relegated to secondary payloads. We decided to fill a whole Falcon 9 with small sats, making it cost effective and therefore enabling new technologies, taking an unprecedented number of first-time flyers up. We've got startups, ongoing businesses, space agencies, museums, universities, even a middle school aboard. Missions themselves vary from tech demonstrators to Earth observation, communications to biological experiments. Spacecraft come from 17 different countries, represent the work of thousands of people. A mission this size with 64 spacecraft takes years of planning and draws on our deep expertise in launch. Our engineers designed two rings, the upper and lower free flyers, that will separate and deploy their spacecraft in a series of orchestrated maneuvers. Because we have launched over 140 satellites to date, we've experience with nearly every different SEP system and dispenser and are always ready with custom solutions to deployment problems. Our engineers and mission managers were fully up to the challenge of a dedicated mission. Assembling the integrated stack was like putting together a giant, complex puzzle. It was a master effort in project planning, ingenuity, and perseverance that took place in our new state-of-the-art integration facility in Auburn, Washington. Our team also worked with our customers to navigate all the regulatory, licensing, and insurance challenges that come with putting a spacecraft on orbit. Particularly for our first-time flyers, making sure that everything is running smoothly is part of the turnkey service our mission managers provide. Finally, I'd like to say this would not have been possible without SpaceX and the incredible capabilities of the Falcon 9. We all envision a world where small sats are really making a difference. All kinds of applications, Earth observation, new lunar missions, space manufacturing, stuff we can't even dream about. We really want to say how grateful we are to Planet for being the primary on this mission, for SpaceX for enabling it to happen, and for all of our customers that are sharing this ride with us.
As we mentioned, there are 64 satellites on board today. One of these payloads is part of a collaboration between the Los Angeles County Museum of Art, or LACMA, and artist Tavares Strachan called Enoch. Enoch highlights the story of Robert Henry Lawrence Jr., the first African-American astronaut. Lawrence passed away in 1967 in an airplane accident during astronaut training, and he was never able to realize his dream of going to space. The artist sought to honor this legacy by creating a 24-karat gold canopic jar, which is the same shape of jars used in ancient Egyptian mummifications. The jar has been mounted with Lawrence's bust on its top, as you can see there. The Enoch sculpture will be sent to orbit, and once in space, it will circle the Earth for 7 years before deorbiting. SpaceX is a founding sponsor of LACMA's Art and Technology Lab, which sponsored the development of this project. We're now heading into the final countdown, so let's get a status update on the rocket.
With just a few minutes to go before liftoff, everything is looking good on Falcon 9. Fuel is fully loaded on both stages, and LOX is getting there as well. At T-minus 1.5 minutes, we will start vehicle gas closeouts. That's completion of all helium and nitrogen gas loading and the closing of all the valves to those systems. Around that time, you'll also see a large cloud of white gas coming out of the TE. This is expected. This is us venting out the liquid oxygen lines on the TE into the air, making sure that excess oxidizer isn't in the path of Falcon 9's plume at liftoff. At T-minus 1 minute, Falcon 9 will go into startup. You'll hear that on the countdown net. This is when the vehicle stops listening to requests from the ground, other than an abort, of course, and instead is controlled by the flight computer from then on through launch.
Welcome everyone who is new to the stream. My name is Dr. Pamela Gay, and I am here to answer your questions. We are in the process of waiting for a SpaceX Falcon to launch from Vandenberg Air Force Base out in California. It is going to be going into a sun-synchronous orbit. This is one that will go over the North and South Poles approximately, allowing the satellites, the 64 satellites it's launching, to regularly see the planet with the same shadows, to be able to better observe how our world is changing. Thank you so much for the bits. Can we light up the chat? Now, as you look at this rocket, you may be noticing that it looks kind of like someone applied a grunge filter in Photoshop. This is because that first stage, the lower part of the rocket, has already been used on 2 previous launch attempts. Thank you so much for the bits, Bill Nash. It has flown back successfully both times, landing either on land or on one of the SpaceX barges. Today's landing will be on a barge. In addition to rescuing that first phase, they are also going to try once again to catch the fairings, the cover over those 64 little satellites that have been puzzle pieced together into that top wider part of the rocket. Those fairings, well, we haven't caught them before, and this is going to be one of those cases of using a speedboat to zip around, basically going, I got it, I got it, I got it, in the ocean. I don't know how they're going to catch it. I really don't. But here's to hoping we get some video of what exactly is going to be going down. So we are now a minute 30. Thank you so much for the bits. We are now a minute 30 from takeoff. Here they are releasing gases as expected. Very noisy outgassing. I don't know if the speedboat is a robot. I think it is, but I could be entirely wrong on that one. Thank you, Veronica.
Falcon 9 is in startup.
So they are disconnecting from their ground-based computers, turning everything over to the computers on board to handle.
Stage 2 is pressing for flight. It's launch drifter on countdown 1. We are go for launch. Gas closeouts are complete.
Thank you so much for the follow.
Stage 1 pressing for flight.
T-minus 15 seconds.
Here we go.
10, 9, 8, 7, 6, 5, 4.
All we want is
3,
nominal.
2, 1. Lift off of the Falcon 9.
This is the scary part. Things like to blow up in the first couple of minutes. It's not until that first stage has finished running down and been deployed that we can start
nominal.
to breathe a little bit.
Falcon 9 has cleared the tower and is now headed upward on its mission to sun-synchronous low Earth orbit. Coming up, the rocket will throttle down for max Q, which represents the maximum aerodynamic stress on the rocket. We're now headed into a series of events that will occur in rapid succession. That's MECO, stage separation, and SES-1, or second engine start 1. MECO is the shutdown of all 9 first stage engines in preparation for stage separation, where stage 2 separates from stage 1, and SES-1 is the ignition of the second stage engine.
And back chill has begun.
Following SES-1, we will turn our attention back to the returning first stage, which will relight 3 of its engines in a boost back burn to head back towards the drone ship. And then finally, we'll see fairing deployment at T plus 2 minutes and 43 seconds.
There's the California coast.
As mentioned earlier in this webcast, we're attempting to recover the payload fairing, and while we will not have a live video feed of this attempt, we'll share updates as they become available.
So they will not be streaming the catching of the fairing
about 20
in
seconds,
the Netty boat.
You'll hear the call out from MECO. Let's listen in.
They're launching 64 satellites.
We have MECO.
So there you can see the separation of the first stage. It will now fall before coming in for a nice, polite landing.
And as you just saw, we had a successful main engine cutoff, stage separation, as well as ignition of that second stage engine. And there goes that fairing. And there you can see all 64 of those satellites on stage 2 headed to sun-synchronous orbit.
And now they're going to try and catch the fairing as well. Now, you don't need the fairing as soon as you get above the atmosphere, because the fairing is there to protect the payload, in this case 64 satellites puzzle pieced together.
In a couple of seconds. That's where stage 1's burn, that brings it back in the direction of the drone ship. That burn will cease.
Stage 2 trajectory nominal.
And we are hearing that the stage 2 trajectory is nominal and performing as desired. You can see those beautiful grid fins popping up on the left side on stage 1 as it makes its way back down to the drone ship. MVAC-D's power is nominal. That burn is looking very good.
And we're looking at another launch tomorrow, 24 hours from now from Cape Canaveral. So as one goes up, the other goes down. We are continuing to see the firing, in this case, of the secondary engines, as our 64 satellites, still puzzle pieced together, continue their journey to low Earth orbit in the sun-synchronous polar orbit.
Stage 2, MVAC-D engine continues to look good. Temperatures and chamber pressures remain nominal.
Nominal's all we need.
We have beautiful views of the Earth from both stages.
So they don't actually know at
So
this
just a
point.
quick recap in case if you have just joined us. We just had a beautiful liftoff from Vandenberg Air Force Base, our West Coast launch site in California, followed by amazing footage of stage separation, main engine cut off first, then stage S separation. And we see the second engine, they're ignited and carrying our payloads into the proper orbit. Now on the left side of your screen there, you see our first stage, which is coming back down to planet Earth as we're hoping to land it on our drone ship this morning. So coming up in just a few seconds, we'll be initiating the re-entry burn. This is designed to slow the rocket down as it re-enters Earth's atmosphere. Then just a couple minutes later, we'll perform the final burn, also known as the landing burn, and that will decelerate the vehicle to a gentle landing atop of our drone ship. So there's the visual confirmation of that re-entry burn. This will last for another 10 seconds.
10 more seconds.
Okay, so now that re-entry burn has ended, we have less than a minute until that third and final landing burn will happen, followed by touchdown.
So it looks like we have engine shut off on the second stage. I'm waiting to hear confirmation.
Now, as we approach our first stage landing, I'd like to point out that we might lose video coverage out there on our drone ship. There's lots of vibrations as the rocket is coming down towards it, so we might lose our satellite signal. If this is the case, we'll be sure to provide you status updates on that first stage as they become available. We're certainly excited to hear about it here in Hawthorne and across all of SpaceX, as this is the first time that we are trying to land this for a third time. So there we can see that final landing burn happening.
So these are fully steerable rockets. They can actually control to fight against wind. And what amazes me is they're going to land this on a boat, and it's going to stand upright. Here it comes in, and we have touchdown, and let's see, does it fall over? It did not fall over.
So as you can hear from the crowd cheers here, Falcon 9 has touched down for the third time.
We don't yet know exactly how many landings these things are good for, but 3 seems to be a good number, and they trusted it enough to launch 64 satellites with it. So now we're waiting to hear on the fairings.
32 seconds into flight, and the second stage is still burning nominally. It's on a really good trajectory. Power is looking good, chamber pressures are good, and we're looking at 200,000 pounds of thrust in the vacuum of space with that engine.
So they are continuing up.
So the second engine cutoff, or SECO, that's where we're going to stop burning this engine, because ideally Falcon 9 will be in its intended deployment orbit. That's coming up in about 50 seconds.
And then once they're in orbit, they will deploy the satellites, giving them each a slight delta V so that they don't hit each other over time, and orbit the Earth as required for their various Earth science and communications needs.
So as we mentioned earlier, we won't be able to show the deployments of the satellites today because this will be happening, that will be taking place over areas where we don't have ground station coverage. So unfortunately, we won't have any live video feed to provide. Because deployment won't be viewable, we will end our live webcast soon after the second engine cutoff, but please continue to follow along on SpaceX Twitter updates for payload deployment as they become available.
I'm suspicious that they aren't saying anything about the fairings.
We should be expecting SECO, and there it is. Let's listen in for whether or not the orbit's good. And we have confirmation that stage 2 has reached a good orbit. This is the deployment orbit, and the next step over the course of the next 40 minutes or so is to separate the payloads from the second stage of Falcon 9. And with that, we have reached the conclusion of our webcast today. Please continue to follow on SpaceX Twitter for real-time updates on the rest of this mission, including deployment of the satellites on board today. Thank you to our customer Spaceflight for entrusting us with today's launch, and to the United States Air Force's 30th Space Wing for range support. And a special thanks to the FCC, the NTIA, and NASA Spectrum Office for helping making today's flight possible.
Be sure to continue to follow along with future SpaceX milestones. Check out our website and social media feeds. Also, be sure to check us out for our next flight, CRS-16, a NASA cargo resupply mission to the International Space Station. And that's currently targeted for tomorrow, December 4th, at 1:38 p.m. Eastern out of Cape Canaveral, Florida. And with that, from all of us here at SpaceX, have a great day.
So thank you all for joining us for this crazy day of amazing coverage of all the things that are going on. People often say, what's NASA up to? We can't launch our own humans into space. Well, you don't need to launch humans to do the science. Between SpaceX, between NASA, between all the different agencies out there, we are able to continue meeting all of our communications, science, meteorological, entertainment, all the different space-based needs we have with launch after launch occurring on a regular basis. Our world is no longer limited to the sky. We are up and above the clouds. Thank you for joining us today. We will be back tomorrow to bring you the daily space at 1 p.m. Eastern, and then we will follow on covering tomorrow's launch of yet another SpaceX Falcon. They're referring to it as a hat trick, bouncing between coasts, and we're going to follow along and see just what they're able to bring for us. Now, as always, we are here because of you. Give us a follow to find out when we go live, and Your subscriptions and your bits really make a difference. It's how we pay our bills and keep our team going and bring you, well, all sorts of interesting and amazing ways to not just learn science, but to also do science. I encourage all of you to check out CosmoQuest.org, your place to help us map out other worlds. Coming up in a few months, we will be working with the OSIRIS-REx team to create the first ever maps of the asteroid Bennu. And we're going to be working with them to find that rock that they're going to bring home to the planet Earth. Thank you so much for the sub, Prof. Melko, and thank you all for being here. Wherever you are in the world, go out and have an amazing morning, evening, and afternoon. And remember to look up. Thanks. Bye-bye.